this computer. Yes, so welcome everyone. Welcome to the open source community meeting on 2nd October. I would like to start today with a very short welcome note. I would like to reiterate once again on the format of the call. We are going to do this meeting for now bi-weekly. In the meeting, we are going to have two 20-minute talks by our community members. It's much appreciated if the colleagues that are presenting could also do video so that we can see who is speaking to us. We are going to do our best to have all the time a 20-minute open talks where we can still discuss other topics that are maybe not on these particular talks, but are interesting for us. And we would like to make sure all the recordings are uploaded to YouTube so that in case someone is not able to join because of the time zone, you still have a chance to watch the recording later and yeah, somehow engage over Slack or some other channel that works for you. All the presented materials are in the Google Drive, and you're welcome to join the Google group so that you get the meeting requests that we are sending automatically. And if this is not working for you, don't worry, you just follow the Twitter or the Slack and you can still manage that on your own. Good. With this, I would like to present the speakers for today. We're going to have Andrey. Andrey is going to talk a bit about the machine controller manager provider for Yandex.Cloud. That's a contribution that he's currently working on. And we'll be very interested to know how this worked for him. What were the key reasons he had to do that? What is his plan for the future? How did that contribution work so far? What were the hurdles, what worked, and what is coming next? The second talk that we are going to have today will be from Stoyan. Stoyan is going to share with us about the Kubevirt integration. So with this, I think I can hand over to Andrey. So Andrey, if you would like to take over the screen sharing and show us your presentation.
Sure. Hey. Okay, is it working?
Yes, we see that, yes.
It's my first time in the community meeting with you, but I've been contributing to, well, my name's Andrey Klimentyev, I work at Plant. I've been contributing to Machine Controller Manager for the last half a year. Already 11 pull requests. Would like to make this number higher. Well, I work at Plant. We provide DevOps services. We are a Kubernetes certified provider and a silver member of the CNCF. Well, we've realized a need for we've had a large amount of clusters, and we realized the need for automation 3 years ago when the number of clusters shot through the roof, and we wrote our own Kubernetes distribution. And well, to manage the compute resources for it, the Machine Controller Manager is an integral part of it. What's Yandex.Cloud? It is a leading IT company in Russia that's widely known in the last decades. It is offering, forgot the sentence, a managed Kubernetes distribution. It's offering its cloud services. The important difference of their services that stand them apart from other ones in Russia is that they have a proprietary implementation that works really, really well. It is not a rebranded OpenStack or vSphere product. They have robust gRPC and REST APIs and also provide a lot of SDKs for different languages. A lot of our customers use the Yandex.Cloud, so we had to create some computing machinery around it. But it doesn't come without its own quirks. But before we talk about them, we have to review how Kubernetes integrates with clouds. We've got two main things. First of all is the CSI, Container Storage Interface, and it's all about volumes and how you provision them, mount them, etc. And you also got the Cloud Controller Manager, and some people, mainly the VMware guys, call it the CPI, Cloud Provider Interface. And it manages load balancers, roles in the row tables inside the cloud. It also provides a provider ID for the nodes so that we can map nodes to the virtual machines. Now, the fun part about the Yandex.Cloud is that it has a managed Kubernetes offering, but it has not open source either CSI or CPI that powers it. We've had some talks with the Yandex representatives, and the main reason that they state is they operate with some internal APIs, but almost a year passed, and well, where the vendor slacks, the community provides, and we wrote an open source CSI and CPI implementations, which we use day to day for almost a year. And the MCM out of tree provider that I've contributed for the machine controller manager supports both our implementation and the way managed Kubernetes provides the provider ID and how it manages volumes. So if at one point of time the Yandex.Cloud guys and gals would be willing to finally open source their CPI and CPI, we'll be ready and we'll support it out of the box. Now, about the whole contribution, it is rather curious because we aren't invested in the whole Gardener ecosystem and whole Gardener project. Our contributions, my contributions, are limited to the machine controller manager. And well, if someone is willing to work with us implementing the Gardener, Yandex provider for the whole Gardener ecosystem will be delighted to help. But for now, only the machine controller manager is what interests us as a part of our Kubernetes distribution. And as for the future, there are some unit and integration tests that I'd like to add, because I test everything with the debugger, and that is not how open source projects, stable open source projects should work. And I'd also think, before talking about the next thing, we've maintained in-tree providers in the closed repo for vSphere and Yandex.Cloud for the past year and a half, year mostly. And when the whole initiative with the out-of-tree providers came to light, I've immediately jumped on the ship and tried to open source it. But I've found some issues with the current machine control implementation, and we are currently talking with Prashnet on this issue that you see on the screen. That's it. If you like it, check it out. It was Andrey Klimentyev from Fund. Thanks for having me.
Super, thanks a lot. So do we have questions to Andrey? Feel free to unmute and ask something.
Andrew, this is Hardy. You mentioned about vSphere, right? And since recently, we also have our own MCM vSphere provider. Had you have a chance to look at it? And
yeah, I'm well aware of it, and it is on my list. But we've got some things that we've implemented in our in-tree provider. Mainly, we are identifying VMs not by custom attributes, but by tags, which are separate entities in vSphere. And I'll get my hands to open sourcing our things and trying to to merge them upstream in October probably, and then we will try to use that as well.
Perfect, thanks.
Cool, thanks a lot, and thanks a lot, Andrey, for making the time to share your experience so far, and looking forward to see the next steps that you have in mind. And I think with this, we can hand over to Stoyan. So Stoyan is going to, yeah, feel free to unmute. I think, yeah, your co-host, so you should be able to share screen already.
Yeah, let me share my screen. So my name is Stoyan Rachev, and in the last okay, you should see something now.
Yes, we see the screen. Yes.
Okay, great. So in the last 2 to 3 months, I've been working together with other colleagues on integrating Gardener with Kubevirt as a provider. And today I would like to talk a little bit about what we have achieved so far and also show a demo how the integration works. Okay. Yeah.
And we also now know you're very brave to use the web version of PowerPoint.
Okay, I'm really sorry about it, but I need to do something small on my slide. Don't know why this happened. Okay. I would like to start with general garden architecture. It should be familiar to most of you, but just in case, because I'm going to refer to a lot of these concepts later on. So in Gardener, we have 3 types of clusters. In the so-called garden cluster, it's the Gardener control plane itself, including the API server, the controller manager, the scheduler, dashboard, and other central Gardener components. We also have seed clusters where we host the control planes of the Gardener mange clusters that are known as shoot clusters. So for each shoot cluster, there is a dedicated namespace in the seed that contains components such as the API server, etcd, controller manager, and so on for the shoot. And in the shoot cluster itself, it has only worker nodes, no master nodes, because there's no control plane. And this is where the actual user workloads are running. And now talking about Kubevirt. So what is Kubevirt in the first place? Kubevirt is a way to run VMs inside pods. Put it very, very simply and very naively, probably. But what happens is you are giving Kubevirt a definition of your virtual machine in a Kubernetes cluster that has Kubevirt installed, and sometimes additional components such as CDI and Multus for network management. Based on that definition, Kubevirt will create that VM for you, and this VM will be hosted in a pod running inside this cluster. We call this cluster a provider cluster. You can see this at the bottom of this diagram. So the whole idea of Kubevirt integration is to be able to use the VMs created in this way for worker nodes for shoot clusters managed by Gardener. The provider cluster has to meet certain criteria. It needs to have so-called nested virtualization installed or configured properly. This is possible on at least some of the cloud providers. We will see later in the demo, we'll be using GCP as a cloud provider. And this is also possible in OpenShift. One of the main motivations for this project was being able to integrate with OpenShift, where Kubevirt is basically part of the offering. And this is our way to integrate and run Gardener mange clusters on top of OpenShift. But as you can see also today in the demo, the things that we did for Kubevirt is an open source project, are independent of OpenShift and can be run and tested on any provider cluster that meets the criteria for running Kubevirt. Okay, and how do we do it? We have 2 extensions. We have the so-called provider extension, and we have the so-called MCM extension. The MCM extension for Kubevirt, that's basically the same type of extension that was just presented. For Yandex, it's just that we are now, this MCM extension is targeting Kubevirt as a provider. Now, what does let's dive a little bit deeper into the Kubevirt provider extension. It hosts, as every other provider extension, maybe you know that since some time, all integration of Gardener with cloud providers is out of tree and therefore relies on similar provider extensions. So every such extension has these three types of controllers: the infrastructure controller, the control plane controller, and the worker controller. The infrastructure controller configures network communication between the shoot worker nodes. The control plane controller, in the case of Kubevirt, deploys the cloud controller manager, which plays a rather important role in managing the shoot cluster properly. It's a standard Kubernetes component, but it needs to be implemented for every cloud provider in a different way because it contains some cloud provider specific logic, mainly for managing nodes, services, and services of type load balancer. And finally, we have the worker controller that's actually responsible for creating the shoot cluster, managing the shoot cluster worker nodes. And it does it by actually delegating to another standard Gardener component known as the machine controller manager. Machine controller manager will reconcile resources such as machine deployment, and out of it machine set and machine. And in the process of reconciling the machines, it will call into a special provider-specific plugin, which is our second extension, and that's the Kubevirt MCM extension. And this extension is responsible for actually creating, deleting, listing machines, which in our case are Kubevirt virtual machines. In this way, implements the provider-specific logic for handling machines. Okay, and yeah, last but not least, just wanted to mention, this is I'm going over this very quickly, but there is some documentation you could go and check. For example, yeah, okay. Yeah, no, sorry. What I wanted to say, there is this. There are these are the Git repos for these two extensions. If you wanna go deeper into the implementation. Interesting. Okay, and some of the aspects can be configured. So there are two types of configuration that we can have. There is the configuration that is done by the Gardener operator. The Gardener operator is responsible for setting up the so-called landscape, where preparing basically the garden cluster, the seed clusters, and making sure that shoot resources can then be reconciled. This person deals with the resources such as the seed and the cloud profile resources. I'll show them in a minute, so I'm not going to show that in detail. If you're interested, there are links that you can click on for more detailed documentation. And then there is the user. What the user does is preparing the actual shoot resource that will result in, after reconciliation, creating and then also maintaining a Gardener shoot cluster. And the user also has to provide the so-called provider secret, which enables Gardener to access the provider infrastructure. And in our case, the provider infrastructure is just another Kubernetes cluster. It's the so-called provider cluster. So our secret contains the kubeconfig of this cluster, And all objects, all Kubevirt related objects, such as virtual machines, data volumes, network attachment definitions, and so on, will be created in this provider cluster using the credentials provided in that secret, and also using the namespace present in that secret. Default is implied if a namespace is not configured. Inside the shoot resource, there are several sections that are provider specific and can contain additional Kubevirt specific configuration. There is the infrastructure config, control plane config, and worker config sections for the 3 controllers respectively. And again, if you are interested in more details, there is the link to the documentation that provides the details, what can be configured and in what way. Okay, and now let me jump to the demo, and hopefully many of the things I went very quickly, but during the demo I'll be showing some of them in a little bit more detail. Okay, so let me first describe my setup a bit. So I'm running Garden on my local laptop. So I have a cluster on my local laptop that serves as the Garden cluster. And for the sake of making it easier to see what happens, I here have the logs of the so-called Garden-led components. That will do the most of the shoot reconciliation, and that's a standard component of Gardener. So we'll be looking at these, and I'm using a seed cluster that is hosted on GCP. It's just a normal GCP cluster. Of course, it has been created by Gardener as well, but that's a detail. Could have been any cluster, to be honest. And if we look at what kind of shoots do we have right now in the seed, you can basically see them listed here. There are 2 shoots. This shoot here, GCP VMX, is not a Kubevirt managed shoot. It's a GCP shoot, but it has virtual nested virtualization enabled, and it also has Kubevirt installed. So we'll be using this cluster as our provider cluster to create another shoot. And this is our provider cluster. You can see right now there are no virtual machine instances, nothing basically in our default namespace. If I list pods, there are no pods as well, and so on. So let's look at our shoot definition. It's a quite basic shoot definition. I have no special infrastructure and control plane configuration, and therefore you don't even see these sections here. For the worker pools, I have a single worker pool with referring to an image known as with the name Ubuntu that is defined in my cloud profile. And in my provider config, I have a single option to disable the so-called pre-allocated data volumes because for whatever reason, we currently have some issues with that feature, and therefore I prefer to disable it to not disrupt the demo. And in the shoot definition, you can also see the region for our shoot. These are all, of course, GCP regions. Since our provider cluster is hosted in GCP, we'll be using in our shoot GCP regions as well. We have the secret that contains the credentials, or basically the kubeconfig for our provider cluster. You have networking ranges, Kubernetes version, and other options that are not so interesting. So let's apply this shoot. Okay, right after applying my shoot, I can see in the Garden-led logs that something starts happening. we have the shoot cluster reconciliation already running. And if we take a look at the seed cluster, you can see that in the shoot namespace that has been created for us, there are some components already being created. This is basically a standard part of Gardener reconciliation process. You can see the Cloud Controller Manager I mentioned earlier. It appeared as part of reconciling the control plane for our shoot. And at some point, we will also come to the point where the worker is being reconciled. We need to wait maybe a few more, maybe a couple of minutes until that point. Okay, here's the Kubernetes API server popping up. And here we can see some additional components such as the Kube Controller Manager, the Scheduler, and the Gardener Resource Manager also being deployed. And we, at this point, we have already started the reconciliation of the worker pools. You can see the Machine Controller Manager also popped up. And if I look at machine deployments, I will see one machine deployment has already been created. And as a result of this, creating this machine deployment, the Machine Controller Manager has created a machine set. And then from the machine set, a single, for the moment, machine, which is in pending state. And if I now take a look at the provider cluster, I see that in the default namespace, there is something happening. What is happening here? So if I list data volumes is another Kubevirt standard resource, or rather a CDI resource, containerized data importer resource. I see this a single data volume that was created, and there was some import happening. The import that was happening was actually downloading and importing the OS image for the root disk. This is an Ubuntu image you saw previously referred to in the shoot. And once our data volume import has finished, I forgot to mention that basically the Machine Controller Manager extension created a virtual machine object. This is the one that you can see here. So the data volume was actually created out of it. The second object that is created out of it by Kubevirt is the so-called virtual machine instance. And this is our actually running instance. It will have an IP address. And if I list pods in the namespace, you will see there is a pod called virt launcher pod that actually hosts this VM. Now we need to give this VMI some time to properly run the cloud init and join the cluster. How can we know that this is finished? This takes between 3 to 4 minutes, I think, on this setup. One way is look at the gardener logs and wait until basically it proceeds to the next phase. Another way would be to create to our newly, to connect to our newly created shoot. And we can do that by executing a command such as this one, basically getting a special secret and extracting the kubeconfig of our shoot from it. And then here, I should be able to examine the shoot itself. So right now, there are a number of pods, but there are no nodes, and therefore the pods are all in pending states. But as you can see, just right at this moment, a new node popped up as a result of our, you can see the name is the same as the name of our virtual machine instance. So this is the result of our virtual machine actually joining the cluster. It's still in a not ready state because we have a cloud controller manager. The cloud controller manager needs to do some node initialization and then flip it to ready, which just happened. And now that we have a ready node, if we list the pods, we will see that they start, they move now to running or container creating. All of them will wait for the Calico node pod to become running, so that the network is properly initialized before they can actually proceed. But all that use the pod network, that is. So this is somewhat slower here, and we will need to wait maybe another minute until all the pods are in ready state. Meanwhile, the gardenlet has noticed that the virtual machine has joined the cluster. Our machine is, as you can see, already in a running state. So gardenlet proceeded with the other phases of the reconciliation and actually even finished the reconciliation successfully. So from gardenlet perspective, everything is done. Of course, to use the cluster, we still need to wait until all the pods are running. Meanwhile, we can take a look at the seat in the shoot namespace. You can see that we have all the control plane components running here already, and also some monitoring components such as Prometheus and Grafana, and logging such as Loki. All this is again part of the infrastructure gardener deploys for every shoot, unless it's configured differently. And right now, okay, Calico node is running. Our some of our pods are still container creating because they are downloading images, but I think we can already use our cluster. So let's see what could we do with it. Let's do something very simple. Deploy an Nginx pod and expose it via load balancer service. Okay, and then first of all, we need to make sure our pod is running. Still not the case. Okay, now it's running. And then let's make sure the load balancer itself has been created, because yeah, on GCP and in most cloud providers, this takes between 30 seconds and 1 minute until we have the actual load balancer address. So let's look at it. Let's wait for it. Okay, we have it. And now let's just curl this address. And you get the familiar response, welcome to Nginx. That was the expected result. And you saw that you also had, we also had Kubernetes dashboard on this cluster. So let's connect to the Kubernetes dashboard and see if it's also running properly. Okay, so I need to provide to provide proper credentials. I'm giving the kube config for the cluster that I used previously. And I connected now to the dashboard, and you can see the Nginx pod we just deployed already here. Okay, so this is our fully reconciled and fully accessible and working shoot cluster on the GCP provider cluster. But I would like to show another cluster, not reconcile it now, but just to give you an example for some other possibilities that I did not demo here. If I go back to my garden and list all my shoots, of course, we can see the shoot I just created. This is this one. There's a second shoot which uses an OpenShift cluster as the provider cluster. If I look at the definition of this shoot, I can see some interesting things. For example, there is an infrastructure configuration which actually specifies a tenant network for our shoot with a so-called CNI configuration. It's just a JSON snippet for the actual CNI config. And it's also labeled as default equals true, which means that this particular the VMs of this particular shoot will not join the pod network of the provider cluster. Instead, they will be attached to their own network, namely the network we are creating here with this definition. This might be important in real scenarios, mainly for to achieve network isolation, sometimes to achieve better performance, and sometimes for other reasons. So on this network, on this OpenShift cluster, this VXLAN setup that we are using here actually does ensure isolation of the VMs belonging to different shoots from each other and from the pod network of the provider cluster. And in terms of Kubevirt, what does it mean? If I now look at the OpenShift cluster that hosts this this shoot, is the provider cluster for this shoot, and this is the namespace I'm targeting via the kubeconfig. In this namespace, I can also list a resource known as network attachment definition. And if I open it, you will see that it is exactly the same definition we had just seen in the shoot. So this definition has been created and will be managed as part of reconciliation process for our shoot. And if I look at the VMI and take a closer look at the VMI definition, I will see that it's the single network that this VMI is attached to is defined by this network attachment definition. So there is no pod network. You can also see that this VMI shows new as IP address. This is not intended. This has to be the actual, it does have an IP address, it's just not properly reported due to some Kubevirt issues that we are working together with the Kubevirt community to resolve. If we look at the pod, you will see that it does have an IP address, and this is the actual address of the VM as well. And I will be using another pod running in the same network I created manually to SSH to this VM and make sure that it is isolated from the rest of the cluster. Let's do that. So I'm going to execute this command in order to SSH to the VM. And now there is the OpenShift cluster again, but in a different namespace, in the default namespace, which is used for another shoot that I'm not showing here. And the VMs of this shoot are attached to the pod network. So this is the pod network of the OpenShift cluster. Now, the interesting thing is, can I ping this VM or not from my isolated VM? And as you can imagine, ping doesn't work because the network setup is such that these two networks are isolated from each other. Okay. Now, before basically this was the end of my demo. Before I open for questions, I want to show. I want to talk briefly about what is not yet done, or what are the next steps in this project. We do have a number of things we need to improve upon. Even though, from my perspective, what we have achieved already is quite sufficient for interesting use cases, and also for continuing with our roadmap for OpenShift integration. So there is a validation webhook that we need to enhance a little bit, that will allow for validating the resources I mentioned in the beginning, so cloud profiles and shoots mainly. All this custom configuration is something that needs to be validated, and to prevent the user from interesting situations, so to say. There are some additional VM configuration options that we can enable via the worker config in the shoot. I did not, we already enable some. I did not focus on that during the demo, but we have, for example, this pre-allocated data volumes that I mentioned. We have DNS policy and configuration, but we can work on additional things mainly for performance, such as huge pages support, dedicated CPU, disk device cache, etc. There is an issue with a number of things we are considering in this regard. There is also the possibility to add some non-root disks to shoot workers. This is a Gartner feature that is supported by most other cloud providers, and we can enable that for Kubevirt as well. So you would then be able, in addition to the root volume that also has an operating system and so on, to have a number of empty volumes for use in the VM for whatever usage is necessary. We need to improve on the documentation, even though there is some documentation already that can be improved upon. Adding integration tests is on our list as well. And last but not least, some of you have noticed that I did not talk at all so far about storage. And this is because right now, at this stage, we do not support storage for the Kubevirt shoots. The reason is that we want to do it. We could, and as part of our OpenShift integration project, maybe as a temporary workaround, we will likely enable non-storage solutions, such as, for example, Ceph, that is used in OpenShift. But this is not what we consider the final solution for this. We believe that it should be possible for to enable more or less plugging in to the shoot the storage that is available in the provider cluster, independently of the actual kind of that storage, right? So if it's Ceph or if it's something else, anything that is available already in the provider cluster should be somehow brought to the shoot cluster running on top. And there is a concept for such a CSI driver, and we expect to be able to work on it and integrate it later on. Right now, such a CSI driver does not exist, so this has to be developed before we can integrate it in Gardener, and this has to be developed in the Kubevirt community. So hopefully we'll be able to do that in one of the next phases of this project, and in this way complete the picture for basically having a fully functional Kubernetes, I would say, fully usable Kubernetes for whatever kind of workloads then based on Kubevirt. Okay, so that was all from my side. And I think we still have time for questions.
Yes, we have still a few minutes, so thanks a lot. That was very good. And I think we can start the Q&A part, or the open discussion part. So if someone would like to ask questions to the speakers, it's good time to unmute or use the chat, whatever is more convenient.
Hi, Stoyan, this is Tim. Thanks for the demo and the presentation. I saw you enable the connectivity feature gate. Is this setup also working without this feature gate, so with the classical VPN architecture?
Yes, it is working, but with some caveats, and I can show some of these. So the provider, the GCP based provider cluster, when I create a load balancer on it, as you saw, basically, I also demoed that, it's visible externally, and therefore the seed can connect to that load balancer without any issues. In this case, it works. With the OpenShift provider cluster that I'm using, this OpenShift cluster is actually not really. I mean, there is a way to access it from the outside, which I'm using, but this only really applies to the API server of the OpenShift itself. Load balancers created in that cluster use local IP addresses, 1085 IP addresses, that would not be visible externally. And with that, I would not be able to use the VPN because the seed that I'm still running in GCP will not be able to connect to the VPN seed, to the VPN shoot, sorry. So connectivity tunnel enables basically enables using such provider clusters that are more or less closed to be used as well. So it's more convenient, and from this perspective, it has been enabled here and used for both.
All right, thanks for the answer.
Okay, do we have more questions?
Hi, Stoyan. This is Daniel. Thanks, great presentation. I got one question. Do I understand correctly that you are separating the networks by using an overlay network that you pre-created? For instance, using VXLAN, correct?
Yes, I believe it's correct, but to be honest, I did not create this VXLAN setup myself. This is part of our collaboration with Red Hat, and a colleague from Red Hat created this VXLAN setup. And it's actually, I mean, the whole topic of how to properly isolate and manage these networks inside OpenShift so that to achieve all the desired capabilities and the desired performance, I think it's still open. I think what I was showing is still experimental, right? So it's probably going to evolve. The important thing for the Kubevirt project is that it is possible to specify your CNI config, whatever it may be, and this network definition will then be managed together with your shoot cluster, and your VMs will be attached to this network in addition to the default pod network, or as you saw in my demo, even instead of the default pod network. And therefore, you could take advantage to then whatever features this additional network offers. That's the important part from the Kubevirt perspective.
Okay, thanks. I guess from isolation perspective, you always, if you want to properly isolate the shoot clusters, you do not want them connected to the pod network, I guess. So
yes, sure.
So basically, it always requires to hand over like this CNI, the bare CNI configuration. Is there would there be a possibility? Not sure if that's possible for Gardener, that this is managed under the hand, that you can basically provide this CNI or this VXLAN configuration for a bunch of shoot clusters, and then Gardener knows what VLAN ID, for instance, or VXLAN ID it has to hand over to the shoot cluster. Would that be possible? Because then you don't have to configure the CNI configuration for each shoot cluster. Because at the moment you always have to know what VXLAN ID is free, what other shoot clusters are there, because if you don't know that, you can't, at least to my understanding, you cannot create a shoot cluster, because if you would pick a VXLAN ID that's already taken, somehow they might end up in the same network,
yes,
right?
Yes, I understand. What is possible right now, you can find it in this document, basically. There are two possibilities. Either you provide the full CNI configuration, which is if you want your network to be born and die together with your shoot, you should do that, basically. Or you can reference an existing network attachment definition in the provider cluster for a network that exists independently of any shoot and therefore can be attached to multiple shoots at the same time. I believe none of these possibilities is what you are asking for. We are, as I said, we are rather in the beginning of in terms of the actual network setup that we want to offer, and specifically in the OpenShift case, what that should be. And what you are suggesting is probably a third possibility that we would want to offer at some point. But right now, I don't really know because this is this really is something to be born out of our collaboration with Red Hat in the future.
Okay, yeah, cool. It just seems to me like this would be a configuration of this provider cluster and not of the shoot cluster itself, because the network is tied to the provider cluster. But yeah, okay, it seems perfect. I mean, the provider clusters itself seem to be shoot specific anyways, right? Because you provide them via the secret. So they are not used by, these provider clusters cannot be used by shoot clusters from different owners. Only the one that has access to this provider cluster can also create a shoot on it, right?
Yes, the same provider cluster can be used by multiple shoots. That's completely possible. But so far, but yes, you're right. I mean, in order to create shoots in the provider, you need credentials for this provider, at least for a namespace, for a single namespace in this provider, and you can use this namespace to create multiple shoots if you want. Without such access, of course, you aren't able to do that, to do anything there.
Okay, perfect. Thank you.
Okay, thank you. So chance for last question, 1 minute left.
Maybe one last question. Sorry. Is that still correct that Kubevirt works with Kemu underneath?
Yes, it does.
Okay. So there is no way to exchange like the underlying VM to like Firecracker or something like that. So it is
not to my knowledge, but to be honest, I'm not a real expert in Kubevirt. We had the colleagues in the team who are real experts. I'm more looking into the integration with Gardener part. So I cannot answer this question with a lot of confidence, so to say.
okay, sure.
Okay, thanks a lot. Then I would propose we finish the call. Thanks a lot to both speakers today, and thanks for all the questions. And have a great weekend.
Bye-bye.
Thank you.